Hello, very good evening. And today's topic is all about the what is machine learning. So, what is machine learning? Machine learning is an application of artificial intelligence that provides system the ability to automatically learn and improve from experience without being explicitly programmed. So, machine learning focuses on the development of computer programs that can access data and use it to learn for themselves. So, the process is very easy, and this machine learning is totally divided into some parts like supervised machine learning algorithms, unsupervised machine learning algorithms, semi supervised machine learning algorithms, reinforcement machine learning algorithm, and those. So machine learning enables analysis of massive quantities of data while it generally delivers faster, more accurate results in order to identify profitable opportunities or dangerous risks. So it may also requires additional time and resources to train it properly. So when we are talking about the training, it's before the internet. Old timers like me entertained ourselves by actually speaking to another, and one reef roaring game was 20 questions. So in which one player thinks of an object and the other player asks. So this question is to determine what type of object it is, and the questioner is allowed to ask at most 20 yes or no in that type of possibilities, like a probability statistic question. So is it larger than the bread box? Yes. So this type of questions and methodology is used in supervised machine learning algorithm. Now all about the TensorFlow. When we talking about the training, it's coming to TensorFlow. And in the game of suppose 20 questions, the questioner starts with a guess. So construct a mathematical expression for the general model. So it's all about, we can say, the construction of mathematics. This is also called the machine learning or how we train the all models. So in that way we can execute the session by calling the sessions run method and formulating the model. So this totally actually focuses on two methods of mathematical modeling. The first involves approximately a set of data points with a shape reshaping. For example, if a system consists of two-dimensional points, you can predict future points by approximating the system with two-dimensional lines. And lines are determined by the equation. Suppose y equal to mx plus c, or we can say mx plus b. So in that way, if we concluding some points in machine learning algorithm, in that way we can get the proper initialization of variables and determining the loss and how much accuracy we want. So after that, if we talked about the neural networks, yeah, if we are talking about the neural networks, those things are also come to play in the machine learning algorithms. And this method of computing loss is called the squared error, and it is one of the many methods available: maximum likelihood estimation and log likelihood estimation. That's all are coming to parts in the neural networks. So accuracy loss, creating variable optimization of class, gradient descent search algorithm, decision tree, those things are totally shortcomings things. And the momentum optimizer is also a very much important part. So what is the momentum optimizer? So the momentum optimizer is nothing but has a lot of in common with a gradient descent optimizer, but it usually converges faster with a reduced likelihood of oscillation. And the momentum optimizer minimizes the loss function through the momentum algorithm, which uses proceeding values of loss gradient to update the current set of variables. So the momentum optimizer algorithm introduce a new quantity of thinking. So this is all about the momentum optimizer, and sometimes we use some type of small equation like theta 1 equal to theta t minus 1 plus vt. So those type of preceding value of accumulation vt minus 1 is scaled by alpha, and it is called as momentum. Now, what is alpha here? Alpha is set of suppose constant value between 0 and 1. And this value indicates how much the preceding state should influence the current state. Applications, and it is important to understand how accumulation affects the rate of convergence. If the optimizer moves quickly toward the minimum, alpha vt minus 1 in mathematical terms will be significant, and the optimizer will approach the minimum even faster if the optimizer is struck between two values. Suppose alpha v t minus 1 will reduce the amount, and which is the value, those will be updated in this parameter, which has suppose a purpose of unlocking or locking parameters in gradient descent optimizer theory. So this is all called the momentum optimizers. So thank you so much for watching this video. If you like, please subscribe for new tutorials on machine learning and AI. And thank you so much.